Hello everyone, this is Grace and I'm here to explain about support vector machines. So for our introduction about the vector machine, mastering machine learning algorithm isn't a myth at all. Most of the beginners start by learning regression. It is simple to learn and use, but it doesn't really solve our purpose because you can do so much more than just regression. If you're gonna think of machine learning algorithm as an armory packed with axes, swords, blades, bows, and dagger, you have various tools that you can use to learn at the right time. As an analogy, think of the regression as a sword capable of slicing and dicing data efficiently, but incapable of dealing with highly complex data. So on the contrary, support vector machine is like a sharp knife. It works on smaller data sets, but on the complex ones, it can be much stronger and powerful in building machine learning models. So what is support vector machine? Support vector machine or SVM is a supervised machine learning algorithm which can be used for both classification or regression challenges. However, it is mostly used in classification problems. In the SVM algorithm, we plot each data item as a point in n-dimensional space, where n is the number of features you have, with the value of each feature being the value of particular coordinate. Then, we perform classification by finding the hyperplane that differentiate the two classes very well. Just look at the snapshot on this graph. Support vectors are simply the coordinates of individual observation. The SVM classifier is a frontier which best segregates the two classes, hyperplane and line. So how does it work? We got accustomed to the process of segregating the two classes with hyperplane. Now the burning question is how can we identify the right hyperplane? So let's understand. First, we identify the hyperplane. We identify the hyperplane. So this is the scenario one. Here we have three hyperplanes, A, B, and C. Now, identify the right hyperplane to classify star and circle. You need to remember a thumb rule to identify the right hyperplane. Select the hyperplane which segregates the two classes better. In this scenario, the hyperplane B has excellently performed the job. Second is that we identify the right hyperplane. Here we have three hyperplanes, A, B, and C, and all are segregating the classes well. Now, how can we identify the right hyperplane? Here, maximizing the distance between the nearest data point, either class, and hyperplane will help us to decide the right hyperplane. The distance is called as margin. So look at the second graph on your right. You can see that the margin for hyperplane C is high as compared to both A and B. Hence, we name the right hyperplane as C. Another lightning reason for selecting the hyperplane with the higher margin is robustness. If we select the hyperplane having low margin, then there's a high chance of misclassification. So let's go to scenario 3, identifying the right hyperplane. Here, the hint is that you use the rules as discussed in the previous section to identify the hyperplane. Some of you may have selected the hyperplane B as it has the higher margin compared to A. But here's the catch. SVM selects the hyperplane which classifies the classes accurately prior to maximizing the margin. Here, hyperplane B has classification error and A has classified all correctly. Therefore, the right hyperplane is A. Now, can we classify two classes? Let's look at scenario 4. I am unable to segregate the two classes using a straight line, as one of the stars lies on the territory of other circle classes as an outlier. Sorry about that. As I have already mentioned, one star at other end is like an outlier for the star class. The SVM algorithm has a feature to ignore outliers and find the hyperplane that has the maximum margin. So therefore, we can say SVM classification is robust to outliers. So let's go to scenario 5. Find the hyperplane to segregate the classes. In the scenario, we can't have a linear hyperplane between the two classes. So how does SVM classify these two classes? Till now, we have only looked at the linear hyperplane. So SVM can solve the problem easily. It solves this problem by introducing additional feature. We will just have to add a new feature. C equals to X 2 plus Y 2. Now let the plot data points at axis X and Z. So here, the points that were considered are all values for C would be positive always because C is the squared sum of both X and Y. In the original plot, red circles appear close to the origin of X and Y axis, leading to lower value of C and star relatively away from the origin result to higher value of C. In the SVM classifier, it is easy to have a linear hyperplane between these two classes. But another burning question which arises is, should we need to add this feature manually to our hyperplane? No. The SVM algorithm has a technique called the kernel trick. The SVM kernel is a function that takes low-dimensional input space and transforms it to a higher dimensional space. It converts not separable problem to separable problem. It is mostly useful in nonlinear separation problem. Simply put, it does some extremely complex data transformation, then finds out the process to separate the data based on the labels or output that we have identified. When we look at the hyperplane in original input space, it looks like a circle. So what are the pros and cons associated with SVM? One of the pros is that it works really well with a clear margin of separation. It is also effective in high dimensional spaces. It is effective in cases where the number of dimensions is greater than the number of samples. It uses a subset of training points in the decision function called support vectors. So it is also memory efficient. One of the disadvantages or cons is that it doesn't perform well when we have a large data set because the required training time is higher. It also doesn't perform very well when the data set has more noise, like target classes are overlapping. SVM doesn't directly provide probability estimates. They are calculated using an expensive five-fold cross-validation. It is included in the related SVC method of Python scikit-learn library. Thank you.